Version 6.5 is now out, and this is quite a significant change compared to previous versions. So we are doing this video to take a closer look at some of those differences. So what we got here, two Maya's open, and that's going to allow me to jump between the new version 6.5 and the previous version to compare and see the differences. So in the first open Maya here, to make it clear which is which, we will just create some text and say that this is going to be version 6.5 in this Maya, and when we're going to compare against is the previous version, in this case 6.450, but it's basically, I'm just going to say old because the differences in the new versions is different from any old version. Alright, we got 6.5, we got old. Now let's open advanced skeleton in both of these. If we go to the about section, you can see here we got version 6.5. I'll dock the interface. Here's the release notes for Advanced Skeleton 6.5 release, and we can see the first item here. It says full matrix node and quaternion nodes optimized. That's what we're going to take a quick look at now in this video. And basically, previous versions had the offset parent matrix options in the preparation rig. There's an option to use offset parent matrix, which not only use the offset parent matrix attributes of transform nodes, but the connection into these, we're also using matrix nodes to do constraints instead of the typical constraints. So that's a major thing here in version 6.5, that even if you don't use the offset parent matrix options, now you will still be using matrix nodes to do all types of constraints. It also uses quaternion nodes to do all sorts of complex twist calculations. So in a nutshell, the rigs are now just much faster. Now, one of the consequences of this is that these nodes that are now required means Advanced Skeleton, as of version 6.5, now requires Maya 2016 or higher. So if you for any reason need to use a Maya version older than 2016, then you can still access on the website the versions of Advanced Skeleton older than 6.5 here in the download sections. Alright, so let's go ahead and build a rig in both these versions. Let's do something a little bit more interesting than the standard biped. Let's grab biped bendy and go ahead and build it for version 6.5, and go ahead and build it for the old version. And to make the rig a little bit more interesting to watch, we will just go ahead and create some boxes for the joints, which we can go in here, box skin, where each box is actually skinned to each joint. And we'll do the same here. Now, in this case, we have version 6.5 clearly written here, so we know that that was the version used to build this rig. But if you need to find out what version was used to build any rig, you can always, at any time, select the top node here called main, open the attribute editor under extra attributes. You will see an attribute here that says version. That will tell you what version was used to build this rig. We can see here 6.5 here. Jumping over to this, looking at the same attribute, you see that 6.45 was used to build this rig. Now let's select any of these joints just to have a look at some. Here I select the chest joint, go over to the old version, and also selecting the chest joints. And if we toggle between the two, you will notice something looking quite different here over here in the channel box. In the old version, these channels over here are blue, whereas here they are yellow. And if we open the attribute editor, you can right click and it'll tell you where these are coming from, and it's essentially coming from various point-oriented parent constraints, whereas in here, these are all coming from various matrix nodes. In the new version, if I select the IK chest, you can see there's some attributes here about what space for this IK to follow. And it says it can choose to follow the main, which is this controller, or it can follow the root. If we compare that to the older version, we do not have these follow attributes. And this is not just the IK chest, this is going to be for every IK controller. So if we grab the arms, switch them over to IK as well, you can see these also have the follow main, follow root options, and here additional follow chest attribute. So essentially for every IK handle in the new versions, you're going to get an option to follow the main, the root, and any IK above it in the hierarchy. So the chest is above the arm, which is why it has the option to follow chest. Let's see it in action. Well, by default, it follows the main, but not the root. So we can say we want to change that to follow root. Now it follows the root controller, but not the chest controller. And if we turn on follow chest, you see now the IK controller is following the chest controller. So we got multiple spaces now built into every IK controller. Okay, so another thing, let's select the root, FK root, on both the old and new version. And if we quickly toggle between the two, you can see there's some differences in attributes here. Now, by default, the spine is using the in-between system, which essentially means we use rotate one of the spine controllers. The rotation will be distributed throughout several bones. Now, in the old version, the option for the distribution is that there is a pre-calculated amount of percentage that's applied to each of the joints, and you can override them. So this weightings. Now, in the new version, we don't have these individual weighting joints, but we do have something called bias. By the way, a option that's both in the new old version is the in-between visibility, which we can turn on here in both versions, and it gives you a controller for each one of these in-between joints for very fine tuning. Now, in the old version, you can see that it was possible to override the distribution of the in-between joints by adjusting the weight joint for each. The new version is much simplified. It's now just a bias attribute. By default, the value is 0. If you change this, let's slide it up to full 10. You can see at 10, this is behaving more like a traditional typical FK. It's just a rotation on a controller is applied completely as the rotation on that joint. You take that bias back to the default 0. It is distributing it between each of the joints equally. Now it's possible if you wanted to enter -10 here. That is an option where if you wanted the very first joint to be completely unaffected. My recommendation is to leave it at the default value of 0 with equal distribution between each of the joints. Now, another attribute in the new version here, 6.5, that's not in the old, is the option for leg lock. And by default, it's set to full 10. Now, to see what it is, let's turn it off. You can see that rotating the root will affect the legs because the legs are affected to the root. But there is now an option that's called leg lock if you do not want this to be affected. Set leg lock to 10. Now you can rotate the root and have any legs or any tails that might be attached to the root completely unaffected. And that goes for whether the bias is 10, as in this case, or if the bias is 0, in which case, without leg lock, you get a fraction of the rotation applied to the legs. So, in the old system, there was no real separate leg lock attribute, although it has similar effect because by default the weight of the first joint was set to 0. Now if the weighting of the first joint had any other value than 0, you can see that would also affect the legs. Another thing is that the offset parent matrix option is still here, and I do recommend using it. It will provides still slightly faster rigs, although now as of version 6.5, the speed difference between offset parent matrix and NOT is not as big anymore. I still recommend using it, but it's good to be aware of the following limitations. It requires Maya 2020 to have this option at all. Before Maya 2020, there was no offset parent matrix. So the major new improvement of version 6.5 is the performance improvement. And in fact, let's do some testing here, comparing the two versions. Let's open Motion Capture Library and grab a motion. And for the sake of comparing, let's turn on the frame rate option. So here we got our version 6.5 rig doing a backflip, and you can see that the frame rate is coming in at about 60, close to 70 frames per second. Let's do the same for the old version here. Mocap library, grab the backflip, turn on the frame rate, and hit play. And we can see the old version here is doing the same backflip and playing back at about 48 frames per second versus about 65 frames per second. And the difference is, as mentioned in the release notes, full matrix nodes and quaternion nodes optimization implemented in the rig. Okay, that's it for this video about Advanced Skeleton version 6.5. I hope you have enjoyed this video, and I'll see you next time.